Today's lesson is section R4. This lesson is focusing on how to factor binomials, trinomials, and polynomials with 4 terms. We'll divide this section up into 2 parts. We'll focus on mainly binomials and trinomials and polynomials of degree with 4 terms. And then the second day we'll focus on how to factor binomials with a degree of 3. These are called a difference of perfect cubes and a sum of perfect cubes. So you should have received, or you should receive, a flowchart on how to factor. If you find factoring very difficult, then you should refer to this roadmap, so to say, until you can get the hang of how to factor. So the very first step always in factoring is you should ask yourself, are there any common factors between all the terms in your polynomial? AKA, is there a greatest common factor? If there is, that is your very first step, to factor out the greatest common factor. After that, ask yourself the same question again, just to make sure that you did pull out the greatest common factor. After you are sure you did pull out the greatest common factor, then you should count the number of terms, and this will help you determine what method you should use on how to factor the remaining part of the polynomial. So for example, if you have a degree of 2, you have to decide whether it's a quadratic or a cubic. Now on our second day of section R4, we'll focus on cubics. So for right now, if you have a binomial, then your only answer should be a quadratic. And you have to decide if you have a sum of perfect squares or a difference of perfect squares. And then it tells you right here how to factor each one of those. If you have a degree of 3, you need to ask yourself if the coefficient of that x squared term is 1 or if it is not 1. And again, then you're given some techniques on how to factor. And then finally, if you have 4 terms, then your only option is the grouping method. Okay, so again, as we go through each of these factoring problems, take a look at this factoring flowchart to help you think through the thought process and hopefully make factoring easier for you. Okay, so let's go on with today's lesson. So the first problem is 12x to the 4th y cubed minus 4x squared y to the 5th plus 8x y squared. So again, your very first step is to decide whether you have greatest common factor or not. And between all 3 of these terms, we do have greatest common factors. For our constants, we can factor out a 4. X's, at most we can factor out 1x. Our y's, we can factor out 2 of them. Okay, now in parentheses, write down what remains. 3x cubed y minus x y cubed plus 2 plus just 2. Okay. Now, when we have 3 terms and we are sure that we factored the greatest common factor out of the polynomial, and if the polynomial that remains should be a degree of 2, we will not be factoring trinomials with a degree of 3 or anything higher than a degree of 3. So when I look at this polynomial that remains, it does not have a degree of 2. So I'm quite confident then that I cannot factor this any further. So this is your answer. Okay, on to example 2. Same idea. First step, do you have a greatest common factor? So why don't you go ahead, write down the problem, and then try to factor out the greatest common factor. Okay, your greatest common factor is a 2x, which leaves you an x squared minus 9. Now the polynomial that remains is a binomial. So look at your factoring flowchart. For binomials, you have to decide whether it's a quadratic or a cubic. This is a quadratic because the highest exponent on x is a 2. From there, you need to decide whether you have a sum or a difference. We have a difference here. And then you have to ask yourself, are the two terms in this binomial perfect squares? Yes, x squared is a perfect square because it's x times x. 9 is a perfect square because it's 3 times 3. Okay, according to your factoring flowchart then, to factor a difference of perfect squares, we write down two parenthesis groups. At the beginning of each one, you write down how that first term is a perfect square. At the end of each one, you write down how the second term is a perfect square. And then in one parenthesis group, you put a subtraction sign. In the other parenthesis group, you put an addition sign. Order on the signs doesn't matter. And that's your final answer. Okay, problems 3 and 4. Okay, problem 3 is similar to problem 2, so I would like you to go ahead and try problem 3 on your own. Good luck. Okay, problem 3 was a difference of perfect squares again. So you just write down how each term is a perfect square, put a subtraction sign in one parenthesis group and an addition sign in the other. And you're done. Okay, problem 4. Again, first step, do we have any greatest common factors? No, we do not have any greatest common factors, so then our next step is to count the number of terms we have. We have 3 terms for this problem. Next question to ask yourself, according to the factoring flowchart, is the coefficient of the x squared term, which I'm calling a, is a 1 or is it not 1? In this problem, it is 1. These are the easier problems to factor when you have trinomials. So we write down 2 parenthesis groups then, and then you're going to think through a little number game. The number game is you want 2 numbers that are going to multiply to negative 28 times 1. So you want 2 numbers that multiply to negative 28 and add to the middle term. Okay, so go ahead, play the number game. You need to give me 2 numbers that multiply to negative 28 and add to positive 3. Okay, well the 2 numbers are 7 and negative 4. So at the beginning of your 2 parenthesis groups, you're going to put down how the first term of your trinomial is a perfect square. So our first term is w squared. So we're going to put w at the beginning of each. And then at the end of each parenthesis group, you put down the 2 numbers that you came up with from the number game. Order does not matter. And that's your answer. Okay, problem 5. Again, this one's all for you. Good luck. Okay, hopefully you got that as an answer. Okay, moving on to problem 6. This time we have 4 terms. So again, your very first step is you need to ask yourself if you have a greatest common factor between all 4 terms. And when you look at all 4 terms, there isn't a greatest common factor that is common between all 4 terms. So then you move on to the next question from your factoring flowchart, and that is how many terms do you have for this polynomial? Well, we have 4 terms. Okay, when you have 4 terms that you need to factor, your only option is to try grouping. Okay, now grouping is probably a very new method for everyone. Typically, you don't learn grouping nor how to factor cubes in junior high. You pretty much stick to binomials of degree 2 and then trinomials. So, grouping. The idea behind grouping is you're going to take the first two terms and factor out the greatest common factor. Take the last two terms, factor the greatest common factor out of those last two terms. Okay, when we group the first two terms, the greatest common factor is a 2y. What remains is a y minus 5w. Okay, last two terms. When we group the last two terms, you need to find the greatest common factor. Now, it will turn out that if this third term is a negative, you must factor out a negative greatest common factor between these last two terms. Okay, so I'm factoring out a negative 3 then. What remains is y minus 5. And there's actually a typo on this problem. Hold on just a sec. Let me figure out how to fix this. We need the 15 to have a w after it. Otherwise, we're not going to be able to factor this problem. And I do want us to be able to factor it. Okay, so with that fix, then that should have a w there. Okay, now after you group the first two terms and you group the last two terms and you pull out the greatest common factors, you now created two terms. This is one term, this is a second term. And the reason why you have two terms is because those two are separated by a subtraction sign. Okay, take a look at your two terms. What is common between these two terms? Well, the parenthesis group is common between both terms. Okay, so then I'm going to pull the greatest common factor out of these two terms, which is this parenthesis group. So when I factor y minus 5w from the first term, I'm left with just a 2y. When I factor y minus 5w out of the second term, I'm left with a negative 3. So there you go. There's your polynomial of 4 terms factored by grouping. Your answer is y minus 5w times 2y minus 3. Now, if I hadn't fixed this original problem and put a w after the 15, the two parenthesis groups would not have matched, and you could not factor this problem actually. So the original expression would have been your final answer. All right, problem 7, I'll do one more factoring problem with you. Well, I'll do one more factoring problem that involves grouping with you. Okay, same thought process. You have 4 terms. I've already looked. I do not have a greatest common factor. So your next step is you group the first two terms, you pull out the greatest common factor. You group the last two terms, you pull out the greatest common factor. Okay, why don't you guys try that step? Look at the first two terms, pull out the greatest common factor, and write what is left from those two terms. Then, from the last two terms, factor out the greatest common factor and write what remains from the last two terms. Okay, so you should have found a greatest common factor of a, leaving you with x plus 2. Last two terms, factor out a 3, leaving you with an x plus 2. Okay, out of your first term and your second term, the greatest common factor is x plus 2. So we're going to factor that out, leaving you with a plus 3 in your second parenthesis group. So your answer is x plus 2 times a plus 3. All right, the last type of factoring problem that we're going to discuss today are trinomials where the leading coefficient, the value of a, aka the coefficient of x squared, is not 1. These are a little more difficult. They require a little more thought. All right, problem 8. So I have 3 terms here. I've already scanned the problem and I do not have any greatest common factors. So I move on. I know I have 3 terms. The leading coefficient is not 1, so I have several methods that I can use to try to factor this. However, before you go ahead and try to use one of those methods, stop and ask yourself if this is called a perfect square trinomial. Now, the characteristics of a perfect square trinomial are that the first term and the third term are perfect squares. So let's say it's in the form ax squared plus bx plus c. A and c have to be perfect squares. Now there's one more characteristic that you have to check to see if this is a perfect square trinomial. B is found by multiplying really the square root of A times the square root of C and doubling it. So I know that looks complicated. Another way to say this is, however A is a perfect square, take that number. However C is a perfect square, take that number, multiply them together, and double it. If you get your middle coefficient of B, then this is a perfect square trinomial. Okay, so let's try this problem. 9b squared. That is a perfect square because it's 3b times 3b. Okay, last term, 25. 25 definitely a perfect square. It's 5 times 5. Okay, so 3b and 5. If I were to multiply those two together, I get 15b. And then if I double it, I get 30b. Ah, that's my middle term. This is a perfect square trinomial. And the way you factor it is you simply write one parenthesis group, which you're going to square. The beginning, you write down how the first term's a perfect square. Second spot in the parenthesis group, you write down how the last term's a perfect square. And then whatever the middle term's sign is, that's the sign that goes in your binomial. So this goes the minus sign. Now again, a fast way to expand this binomial that's squared is to square the first term. 3b squared would be 9b squared. Good, that matches. Square the last term, so negative 5 squared is positive 25. That gives me the last term. Then multiply the two terms together. 3b times negative 5 is negative 15b. Double it, you get negative 30b. Perfect, that's my original expression. So problem 8 was a perfect square trinomial. All right, problem 9. These are the more challenging problems. Okay, I don't have any greatest common factors. I have 3 terms, and the leading coefficient is not 1. So I'm going to go through 3 options on how you can factor this. The first option is trial and error. The idea behind trial and error is that you would write down 2 parenthesis groups, and at the beginning of each parenthesis group, you need to write down 2 terms that when you multiply them together, you would get 6x squared. And then at the end of each parenthesis group, you would write down 2 numbers such that when you multiply them together, you get negative 5. And then you would need to FOIL the rest of this, or multiply the rest of these 2 binomials together, to make sure then that you get that middle term of 13x. That's the idea behind trial and error. And if you don't get it on the first try, then you got to keep on trying and keep on checking your answer by multiplying until you do get the right answer. Okay, now I personally do not like trial and error. It just does not click with me. So let me introduce you to 2 other methods. Now, they are going to seem longer than trial and error because I'm going through and explaining them. Okay, so if you don't like trial and error, then keep an open mind and try either the method of grouping or the box method. If you like trial and error, then you can kind of tune me out if you want and just keep sticking with your method of trial and error. Again, those people that are fans of trial and error are going to think that my other two methods are much longer, but that is because I'm taking the time to go through every single step and explain them very slowly to you. They do become faster. Okay, second method is grouping. To start grouping, you have to play the number game we played in a previous problem. The number game is you want two terms that multiply to the first and last term. So I need two terms that multiply to negative 30 and add to the middle term of 13. Okay, so think through. I need two numbers that multiply to negative 30, add to positive 13. 15 and negative 2 do that. Okay, so for grouping, I am going to take these two numbers and I'm going to replace them with my middle term of 13x. So I'm rewriting the problem. Order doesn't matter here in terms of these two terms. So I still have 13x. I just changed the way it looked. I changed it into a 15x and a negative 2x. Now you could have reversed the 15x and the negative 2x and you will get the same answer. Okay, now I've already taught you how to group, so this should be easy. First two terms, greatest common factor. Last two terms, greatest common factor. And then go ahead and pull out one of the parenthesis groups, and then the other two guys go together. So there's grouping. Okay, now the box method is very similar to grouping in the sense that you're going to start off with this number game here. You need to find two numbers that multiply the first and last terms, and then you need those two numbers to also to add to the middle term. Okay, we already found our two numbers. It's 15 and negative 2. Okay, so for the box method, you draw a box, divide it up into 4 squares. Top left, you put down 6x squared. Bottom right, you put down the last term of negative 5. In the top right and the bottom left boxes, you put down the two numbers that you got when you played the number game. Again, order doesn't matter. So I'll put a 15, we need an x after it, and then a negative 2, need an x after it. Okay, now from each row and from each column, you pull out the greatest common factor. Okay, from this row, my greatest common factor is a 3x. Next row. Now, if a row starts with a negative, you must pull out a negative. If a column starts with a negative, you must pull out a negative as a greatest common factor. This second row starts with a negative because it starts with negative 2x. So I have to pull out a negative, and my greatest common factor would be a negative 1. Okay, columns. Column doesn't start with a negative, so I'm just going to pull out a positive, and I'm factoring out a positive 2x. This column also does not start with a negative, so then I will pull out just a positive 5. And there's your answer. Your expression factors into 3x minus 1 times 2x plus 5. Okay, so 3 methods, all very valid methods on how to factor trinomials. Okay, problem 10. I think I'm going to do the grouping method for this problem. Okay, so grouping. I want two numbers that multiply to 28 and add to negative 11. Negative 4 and negative 7 do that. Okay, so 2x squared minus 4x minus 7x plus 14 2x, x minus 2, negative 7, x minus 2, 2x minus 7, x minus 2. Okay, regardless of what method you used, your answer will be 2x minus 7 times x minus 2. Okay, let's do 2 more problems together, and then you guys are going to have 6 problems to try. No, 8 problems to try on your own. Yes. Okay, so I'll tackle problems 11 and 12 with you, and then you guys are on your own. Okay, problem 11. I'll do the box method this time. So I want 2 numbers that multiply to 6 and add to negative 7. Okay, negative 6 and negative 1 do that. Okay, box method. Okay, so 2a squared, 3b squared, so negative 6ab, negative ab. Okay, first row, pull out a 2a. Second row, pull out a negative b. First column, pull out an a. Second column, must pull out a negative, and it'll be a negative 3b. Okay, so there's your answer. 2a minus b times a minus 3b. Cool. All right, last problem we're doing together is problem 12. All right, problem 12. No greatest common factors. I have 2 terms. I need to decide if it is a difference or a sum. It's a difference, and this is a quadratic because it could be 4x squared times 4x squared. Okay, so this is a difference of perfect squares. Okay, factoring a difference of perfect squares. Last spots in the parentheses, write down how negative 1 is a perfect square. It's 1 times 1. How is 16x to the 4th a perfect square? It would be 4x squared, 4x squared, minus in one, addition in the other. Now, on every single factoring problem, before you move on to the next problem, you should look back at your 2 factors and decide if you can factor any of those factors again. This one, we can actually, because it is a difference of perfect squares. Okay, so since that's a difference of perfect squares, it would factor into this. This guy can't be factored again, but I do need to bring it down as part of my final answer. Okay, so then this is my final answer, because I can't factor any of these 3 factors again. Okay, so you guys have 8 problems to try on your own. And I wish you guys good luck. Okay, now I know you are not finished with these 8 problems, so at this time you should press pause on the recording, and then once you are finished with the 8 problems, then you can press play and you can check your answers. Now, I will not be talking you through any of these 8 problems. I will just show you the answers. So go ahead, press pause on the recording at this time. And then when you're finished, you can go ahead and press play and you'll see the answers to these 8 problems. I do also have notes that are not part of a recording on my website, so if you want to, you could just refer to that as well. Okay, so the answers to these 8 problems are so there are problems 11 through 20. We already did 11 and 12 together. So really those are the answers to problems 13 through 20. And I do have a little bit of work for some of them. Okay, so I wish you guys good luck with factoring. Again, if you are struggling with any of the concepts in this class, do not wait until the day of a test. Make sure you are getting help from someone before tests and quizzes come around. Good luck to you and have a great day.